It's time. All right, we made it. Let's get a little to do here. So just talk about some Python topics, and let's just see what we can do here. So last time we talked about object-oriented programming, which was OOP. So we're going to go back over that code from last time. Type. And I want to look at decorators. And we're going to start with setters and getters. This relates to object-oriented programming. So it's a nice transition. And then we'll build a custom decorator. And I feel like I did want to find some other stuff here. So let's see what that is. Maybe class methods, the actual class property, the class decorator. I don't use that one very often. But it can have its uses. So I'll go take a look at that, see what it is, and what can be done with it. All right. So let's go back to the object-oriented programming code and just kind of look over that and see what we did. I had it in this file called new, and I actually kind of need to rename that because that was just like made for temporary use. So we can close this and let's just move it. And we can call it like OOP review. There we go. Alrighty. So the last stream where we reviewed object-oriented programming, we were able to do a few things. We looked at the different type hinting in Python, and we saw that it's good to have something like type checking, like this MyPy library. And if we go down here and we do a pip list, see that somewhere in here in my actual libraries should be a MyPy. Yeah, so I have the MyPy extension in here to help with type checking. And if you're going to do circular imports, like if you're going to have an object, I'd be watching, 81 says, I'd be watching right now, but we're at dinner. So once we get back in, I'll tune in. Cool, thanks. I appreciate it very much. Thank you for checking in. But yeah, so the future annotations allows us to do circular type imports or to reference a class from within itself. So whenever you have a class and it's going to receive another instance of vehicle, so like this vehicle, it's going to receive another instance of vehicle in this add function. It's referencing itself from inside the class. So without this future import annotations, that type checking method actually shows up as an error. So we need to have the future annotations to resolve issues like that. And then to create a new object, you basically just use the class. We decided to go with a vehicle. It makes itself pretty open to inheritance, because then we could define a car and a motorcycle and build it off of the vehicle. And that actually works out really nice. Then the main thing we looked at for the object-oriented programming is the first thing, which is it's basically like a constructor for the object. It's the code that runs whenever you create a new vehicle. And every method inside of a class, and a method is just a function, so you have def and then the function name. And the first variable inside of a class method, or a method for the object, is going to be the word self, and this refers to an instance of the class. And what that means is down here, when I make a vehicle, as soon as I make it, I have an instance of it. So vehicle 1 is a vehicle. And now if I push dot, I can access the attributes, which are basically variables. We can see engine is just a string and wheels is just an int. And then the functions are the methods. So I can also access the methods. We talked a lot about these dunder methods and how they're special to Python. Like add is associated with the plus symbol, dunder add is associated with the plus symbol, and dunder init, of course, is just associated with whenever you create a new instance of the vehicle. And we just went over a whole bunch of those. And we showed in the documentation where they're all listed. And the first one, of course, was the init, and all we did was copy in the engine and wheels. But the next two dunder methods that we covered that are really important, that should be basically on every project, are the dunder str and the dunder repr. And str is just how this object is converted to a string if you try to print it. And the repr is a more formal representation of this object. And normally what you'll do is you will have this thing become the exact code that you would type if you were to create it. If we were to run this, we would see that at least somewhere. So the repr method is actually broken for our bike because we did not go back and fix it. But it's saying that we would create a vehicle with an engine size of 150 cc's and wheels equal to 2, and that would actually work. But it would not create a motorcycle. That would just create a vehicle. So what we actually need to do is redefine the repr method for the motorcycle if we want to do that. And you can see here we have this to do actually fix the repr method. And that's because it's wrong for the motorcycle, but it is right for the vehicle. And then we tried a couple more, and this is the add. So this dunder add method is for the plus symbol. It's what happens when you try to add one vehicle to another vehicle. The EQ is when you check for if one item is equal to the other. You want to define how it is that we compare these two things to each other exactly. And then the less than symbol is necessary whenever you call any sort of sorting algorithm. So doing dunder LT allows you to create a magic method for the less than symbol, and we decided to compare them with the number of wheels. We did see a bizarre kind of object, or a bizarre error, because normally this other should be a vehicle. And we were getting a warning that the equality check should be a generic type here. And now that's not there. I'm wondering what exactly was causing that error. Well, I saved it and now it shows up. So the argument 1 of dunder EQ dunder is incompatible with supertype object. Supertype defines the argument as object override. This violates the Liskov substitution principle of MyPy. It is recommended for dunder EQ dunder to work with arbitrary objects, for example, def dunder EQ self other colon object to bool. If not in instance. Oh, okay, so they're showing us how to fix it. Return not implemented. Okay, so if not is instance other vehicle. So we can add that. So we can erase the not implemented exception. Raise not implemented. I wonder if we're still going to have these errors after I click save. I just want to make sure we got everything, because this is interesting. I've never actually ran into this because I'm pretty new to MyPy and this very rigorous type checking, which in Python is actually kind of awesome. So yeah, it looks like whenever we overwrite or whenever we define the dunder EQ method, we want to pass it a generic object, but then we only Then we enforce the type that we want to check by using isInstance to make sure it's a vehicle. And if it's not a type of object that we've made this to handle, we just raise a not implemented error. So that way during runtime, if someone tries to compare a vehicle to something else like an integer or something, then it would raise this not implemented error, which we can try to do that. But let's hit save and see if all of these errors go away. Okay, so the raised not implemented should be raised not implemented error. Okay. Yeah, all of these libraries here are just making the code better. So MyPy, Black Formatter, and Rough, just making the code better. Highly recommended. Okay, so now that is a much better implementation of this, and what we're going to do is we're going to steal this and put it down there on the LT operator, because I think the LT operator is going to have the same thing. Let's just check. And I'm going to hit save, and we'll see. So it doesn't have that restriction on the less than operator. That's weird. I wonder what's so special about the dunder EQ method that you want to do it this way. I mean, like less than, you're normally comparing them to each other, and then just checking for them equal to each other. I don't really know why this matters so much. I do kind of want to try to get this thing to fire off, though. So let's comment out our code. And let's just make a vehicle. And we're just going to check if it's equal to the number 1. Because that should raise the error. This should raise the not implemented error. Yeah, so now we get the not implemented error. And it raised from our code here as expected. So this is exactly what we expect to happen. It's just the code is more rigorous now. For what we're doing, it doesn't really matter a whole lot, honestly. Okay. So that has been improved. Okay. So we had this repr, the EQ, and then the less than, of course. This dunder LT is overloading the less than symbol, and that allows us to do sorting operations and things like that. Appreciate the like. Thank you, whoever threw that up there. I did try to add notifications on the overlay on OBS, but I don't know if they show up. So I'll try to keep that within my peripheral vision to see if I don't know how the overlay and events work on the YouTube streaming. I know for Steam it's all set up and it just works very well, but YouTube streaming is not quite up to par with Twitch. Okay. So then we talked about inheritance with the vehicle and the motorcycle and the vehicle and the car. And then we started redefining the methods. I'm not going to go back into this. This is just kind of like you can grind it out and you can correct the repr methods for the car and for the motorcycle. That way they don't save vehicle. And that just kind of is what it is. Because anytime we call the repr method right now, it's going to use the word vehicle. And that doesn't really make sense for a car or a motorcycle. Okay. So the thing that we want to do is take a look at decorators. And what decorators are, they're kind of part, it's just someone else's code. And one of the coolest decorators, I'm going to go over to Fast API's documentation. And we'll drag that on over. Okay. So if we just look at this and we look at the very basic, the most like simple website page that you can make with Fast API, we'll probably see a decorator right here. Do they just have it? First steps maybe? Yeah, right here. So this decorator is just defining this endpoint. So Fast API is backend software. It allows you to write a web server that responds to these things like these www addresses. It allows you to write a website that responds to HTTP requests, is what it does. And normally, if you have a database backend, you're going to do it in something like Fast API. And Flask and Django are the other ones that are extremely common in Python. And then there's another one called Pyramid, which has probably lost a lot of traction. It was kind of gaining some popularity, but I don't know if it's still going strong or not. But yeah, Flask, Django, and then Fast API has been the one that I've used for years, ever since I first saw it. It just kind of depends what you're trying to do. So yeah, this is a decorator, and what a decorator does in this case is a GET. And a GET request is a type of request. There are GET requests, POST request. There's all sorts of different ones, and it's just a different type of HTTP packet that you're going to be sending to the server in the back end. So in this, Fast API just allows you to create an endpoint, and we could actually, if I wasn't inside of a Docker container right now, we could actually run this thing very easily and just have an endpoint, and I could show you. But let's go look at a decorator in a different situation. And when you think of decorators, they always start with the @ symbol, and all it really means is just someone else's code. So that's really all it is. So yeah, let's just go take a look at the ones that you use in object-oriented programming. So one of the things that we did is we talked about how these variables are not private. So these, let's see. So these are instance variables. Self.engine and self.wheels are attributes or instance variables or class variables, depending upon how you really want to call them. But the thing about Python is there's no such thing as a private variable. So there's no way to protect these, because normally when you're using a class, a lot of times it's somewhere else. Like down here in the main event, or the main function, we have this class, and we can just directly set what the engine is. So we're just going to say new engine. And let's just get rid of this stuff. And now we can see that our vehicle has this new engine. So we've went in and we modified and we overwrote this value. And normally you don't want to allow users to do that. So a lot of times when you're writing a class, you're writing an object that lets other people interact with your code, and you don't want them in there messing around with things. So Python has created these things called setters and getters, and it's just kind of it's like a suggestion on how to use the operation. It doesn't enforce it, because there's still no such thing as private values. But what they do is they put a single underscore in front of each value. So now, let me actually do a rename step here. Actually, we don't want to do that. So now we're going to define underscore engine and underscore wheels, and these are essentially considered private variables within the class. You can still access them and you can still overwrite them. And now all of our code is broken because we've renamed this, but now engine and wheels are not defined. And that's because we want to access them through a getter. So instead of using these values directly, and we can access them directly within the class, that's what's considered allowed. But outside of the class, you don't want to do that. But let's define a getter. And normally, so a getter is how you retrieve the value of a variable, and a setter is how you set the value of the variable. But in Python, the getter is actually called a property. So you can see we have this @ property, and this is a decorator that we're going to put around our value here. And we can call this the name wheels, and it's going to have access to self. And all this is going to do is just return the value. And it just returns the underscore dot wheels. And we have now seen a little bit of magic where some of our errors went away. So now this function, this is a function. We defined it as a function. And now we're using it here, but without any parentheses. And that's because it's a property. So now everywhere you access wheels, you can read the value without using the parentheses because this is a property, and you just expect it to return the value. It can do a little bit of other code where maybe you do something here in the property. You don't normally do a lot, but it just returns the value. And now let's do the same thing for the engine. So now you can see we've gotten rid of all of our errors, and everywhere that it tries to read this value, it's actually just going to pull the value from the getter. And we're going to run it, and now we have an error. See, so we're outside of the class here. We're in the main function. We created our new car, and then we tried to set a value for the new car, or for the engine. And again, you're just calling it new engine, but it says now we have an error. Attribute error, property engine of car has no setter. So we don't have the ability to set this. So this is like a read-only value now. And if you wanted to have a value inside of your class that someone interfacing with your class was, like you wanted them to be able to read a value but not write to a value, this is how you do it. And of course, the silly thing about Python, as I mentioned, is there is no such thing as private attributes. So you can see here, I still have, now I have engine, and I have dunder engine, and I have wheels, or not dunder, I have underscore engine, and I have underscore wheels. So I could still just do underscore engine. And now we've still overwritten the value. So these things are like, in Python, I don't want to say they're pointless, but they are also like, they're a formality. So it's just, you do this because you're trying to let people know. You put the underscore there that says like, hey, you should not be calling this thing directly. You should not be messing with it directly. This is part of the class. This is part of the way the object is designed and built. And if you're going to be overwriting it, there's probably going to be some sort of like unexpected consequences, or just maybe you shouldn't be doing it. So now, if we do want to allow the users to set it, but we wanted to have some sort of restriction on it, say like we wanted to allow them to define an engine name, but maybe we had some sort of standard for the engine name, like the engine cannot have more than like 12 characters or 15 characters or something like that. And that's where you can use a setter. So now we have this property for the engine and a property for the wheels, which is the setter or the getter. Let's define our setter. Oh, it's the variable name first. Oops, it's looking away. Let's see. Okay, so this is going to be wheels. And this is going to be a setter. What do we do here? Just set. Wheels is probably how I want to do this. And we can take in a string value. Actually, this is an integer. And let's just go ahead and call this wheels. Okay. Is it a underscore here? Let me see what this error is saying. It may not be a real error. So this is wheels. We have a property at wheels dot setter. Let me try it with the engine because we're trying to write to the engine. So let's do that one real fast. Oops, that's engine. And set engine. Save. It's the same error, but I want to run it and try to use it because this is a MyPy error. It's not a real error. I just want to see if this, like, this is how it should work. Let's see. Property engine of car has no setter. And it has nothing to do with the car, because we didn't overwrite anything in the actual car. At engine. Is it at self.engine? That can't be it. No. Self.setter. Self. Engine. Self done underscore engine equals engine. This is interesting because this should work. Like, I'm gonna go grab the documentation, which I'm staring at, and let's just take a quick look at this. So this is like a sample of code from the documentation. I must be missing something in the spelling because, let's see. I said C equals C, C dot X equals, it doesn't really have a value, 42 print C dot X. 42. Okay. So the property is defined. It's defined with this underscore in front of it. So the variable name is X. It has this underscore. The property uses the actual the name without the underscore. The setter uses that same name but dot setter. I'm not seeing, there's something different here and I'm not seeing what it is. So we have this underscore engine. And it shouldn't be this like using the word engine here and then down here shouldn't matter. I wonder if that's a problem. Let's see. Property def x self. Property def engine self. I'm really just not seeing the difference here. Then engine dot setter. Callable vehicle, and he has no attribute setter. It's saying property engine. And this should be like property X. It actually says I'm the property X. It's kind of hilarious. What is happening with this? The joys. Oh, shoot. It's the name. It's the frickin' name. It's right there. Yeah. Like you don't use the word set. And that gets rid of it. Okay. Yeah, that's the difference. That's easy enough. Okay. Okay, because that name would otherwise it would have had to have been special in some way. Okay, so now we have a setter for the wheels and we have a setter for the engine, and it's just that easy. Okay. Yeah, it does. It looks weird when you have the same definition like this, but it's because you're using these decorators. It gives them a different set of properties. Okay. So now we've redefined this engine, and like the only reason you would do this setter or getter thing is like one, to remind people don't mess with these underscore attributes, and then two, if you want to set some sort of enforcement on this. So like when we set the wheels, like a semi-truck has 18 wheels, so it probably shouldn't be allowed to be set to something greater than that, right? Like if wheels is greater than 18, maybe we raise some sort of value exception, like raise value error. And then on the engine, maybe you want to keep the name short so it's only a certain length. So if it was greater than like 24 characters, maybe you just want to raise a value error again. So let's try to do that. Let's go down here to our car, and let's try to give our car 18 wheels for starters. And it works fine because that was kind of expected. But now let's try to give it 19 wheels. And now we get this value error occurred. And there's no description of it here. Try that again. So now we have this exception, value error, vehicle expected to have less than 18 wheels. So now we can raise this exception with the number of wheels and set some sort of enforcement on, even though we're allowing people to set this property now, we're going to be able to enforce things upon this variable, which does give you another like tool in your toolbox for managing your code. And then we'll just add a description here too. And that is the engine name must be less than 24 characters. So we're going to run into the wheels error, and then let's just set this back to 18. Actually, we can just get rid of it. We don't need to set it at all. And now we just have this like new engine name is too long, and we'll try to set it. And now we've triggered this other one that says value error, engine name must be less than 24 characters. There should be an S on that. And there we have it. So now we've created these setters and getters. And the one that we haven't covered, and the one that is a little bit less important to me, but is still, you know, an option of things to do in here with these I mean, really what we're doing is we're looking at the decorators. And maybe you want to be able to remove the engine from your car, which would be very bad. So this would perform the delete operation on the engine. So now when we call the delete engine down here, I'm gonna put a print statement up here so we can see it happen. And this is where you could do some sort of logging or something like that. Oops. So we're deleting the engine. And down here on our car, we need to get rid of this. And then what we're going to do is we're going to call delete on car1.engine. And this is going to create a problem because when we try to print it, there's not going to be an engine value. We did that all wrong. We have to go directly to the dunder. So you can see that every time it's funny, that's a recursion error. So every time I every time I try to delete the engine, I try to delete the engine. You have to delete the dunder method here, which is the same. So all of these property setter and getter, you should be working with the underscore value, the private in quotes value. Okay, so now we have this error here where there is no engine value. So the reason this got called is because we tried to print out our car. So we called the str method, and when we tried to print it, it tried to access the engine value. And this error was expected because we knew down here, as soon as we delete the engine, we can't really print out the car anymore, the way that this thing is defined. Okay. So those are the very common decorators that you'll use inside of a class. There are a couple of others. One that's worth mentioning is a static method. So a static method is going to be a method that's part of the class, but it doesn't use the self variable. And I don't really know, I don't have a good example of it right now. It's just, usually it's like a helper function that you call a lot from your class, but it doesn't need access to the engine or the wheels or any information about the instance of the car. And let's actually not put this up here at the top, but we can put it down here a little ways before our properties. And it's the at static method and I'm just going to call it static method. So there's no self here anymore. It's just the two different values. And I'm just going to say return a plus b because we're going to do this pretty generically. Because it would be like, what would you ask of a car? Like, what would you want to know about a car or do with a car where it didn't matter specifically like what any of the details of the car were? And it would be something like that. So, or in this case, a vehicle. And I'm having trouble coming up with an example on the fly. So I'm just going to show that this static method doesn't have access to any of the values. So we have our static method, vehicle static method, and we're going to go down here and call it. And we're just going to do 1 plus 2. So we're going to see a 3 printed out after we print out our car. We need to stop deleting our engine now. So let's not delete our engine. And now we've called this static method and we get back this 3. You can see whenever we jumped in here and called it, there's no self. So we can't do anything like self.wheels. There's no, self is not defined here. This does not have access to any of the properties of the vehicle. And it can't really call other methods. It can't call the methods that have an instance of self because this does not have access to self at all. So you can't really do a lot in these things. But a lot of times it's just some sort of helper method that you want access to, that you want it to be attached to the class because you do it often and early and often. It's exactly the same as having it outside of the class. So you could just have it up here because it never ever needs access to the instance variables. So it could just be out here, and now whenever you try to do it, oops. So now it's out there and it has nothing to do with the class anymore. But then you're not calling it off of the car. So the static method allows you to call it as though it's a method of that's associated with the vehicle, or in this case the car. So if you had it outside of the class, you couldn't access it through that dot notation. And that would be the biggest difference, is like when you have a method that does not need access to the class or the instance variables, but you always do it from within the class, then that's just when you would do a static method. It comes up every once in a while. It's like you'll know it when it's like, oh, I'm doing this thing so often, I wish it was just part of the class. Then you make a static method because it doesn't need access to the self. If you find yourself creating a function in here and you never use, or if you find yourself creating a method inside of your object and you have self defined, but you never access it inside. So what you'll notice here is every one of these functions that we've made use of, it uses the word self. And somewhere on your programming journey, you'll find a function in one of your objects that doesn't actually use it. And that's your opportunity to convert it to a static method instead of using the regular class method. Okay, but that doesn't really matter a whole lot. So let's just be rid of it. And we can get rid of that. Okay, so what we want to do is write our own decorator. And that's where it gets kind of adventurous. So let's go to the very top of the file and see how we can go about doing that. So the first thing that we want to do when we create our decorator is create a class. And we're just going to call this something like my first decorator. Or just my decorator. And we're going to give it a under a net method because it's a class. And it's going to have this other magic method in here. And we're just going to pass as well. And I want to go over to the documentation and take a quick look at that. Just so we can show like what the real definition of it is. Okay, so probably not the best definition on here. Let me see if I can find a better one before I bring it on screen. Not really happy with the definitions of it. It's just modifying a class to allow you to create callable objects. So this is just this is how we basically turn this into a decorator. This dunder call allows us to wrap this around other functions. And then when that other function is called, this thing is called instead, essentially. So the way that we turn this into a decorator is whenever we use this, like we're not going to use this directly anymore. We're going to use it as a decorator here, like this. So now we're using my decorator as a decorator onto other functions. It should actually be on a function, not on a class. So let's do it whenever we print. So whenever we print out this vehicle, we're going to have this decorator that does something else on it. This may not integrate with a class very well. I haven't actually tried this. So we need the function here. And then we just have args and kw args. Did they change kw args to kwds? Is that like a new standard? Interesting. Okay. But the thing that we're going to do is whenever this decorator is hit, it's going to pass in the function handle. And what we need to do with our decorator is just store it so later on we have access to this function. So this decorator, when it's initialized, is given this function handle up here, and then our decorator will have access to it. So let's just store that for later so that we can call it down here, because now we can just call it. I gotta ask ChatGPT, should I use this or kwargs? Let's go find out. Usually it doesn't have an opinion on such things. It's got a lot to say about that. Oh, so now it's answering whether to use args or kwargs, and that's a different question. So args is positional arguments, and kwargs is keyword arguments. But that's not really what I'm looking for here at all. Okay, it doesn't matter. So I'm going to call this kwargs, because that's just usually what I call it. It's keyword arguments. And then this is just your regular positional arguments. Okay, so all this decorator does right now is stores a value of the function. Whenever we decorate it, it stores this dunder string method. And now whenever we call this dunder string method that we have decorated, it's actually going to take all of the arguments and put it into this args, kwargs, and call it, and then we call this function that we stored with all of the arguments that were passed into it. So it's just wrapping itself around this function, and right now it's not doing anything at all, but we'll add a few print statements to show that we have the ability to modify things here. Let's just run this and make sure that it is still behaving properly. Missing the positional argument. I'm not surprised by that at all. Let's try this. See if this. I know with a class it gets kind of weird. Yeah, so now the decorator doesn't have. I'm actually not sure how to decorate a class function. So that's or a method. So let me look that up. Because I remember trying to do a logging function that I wanted to just be able to decorate a function, and I would start logging everything that goes into and out of it. And it's really convenient. But the one that I wrote that would work on any arbitrary, like it would work on any function, but if you tried to put it onto a class method, it didn't work. And that's because this self value, I am not sure where it gets passed in up here. I don't know if the instance, I don't know if you can access the instance from inside of a decorator. Let's see. Original function with the self. Yeah. Why? Yeah, see, there's a bit of a problem here because I'm expecting this self is for the decorator. But we need to access the self, the instance that's used in here in the string method. Tricky. I think I'm going to have to add that to the to-dos. I don't want to just like hang out here for too long with that undone. So we'll jump over to a regular function and decorate that thing. Okay, so we'll revisit that and put that down here on these bad boys. What we could do is look at the property. We could look at the setter. I don't think the setter will be defined in a way that actually helps us. Yeah, I can't actually go look at it. I wonder if I can look at property. It's probably not going to be helpful. So it receives self and then callables. Those are the functions. Getter, setter, and deleter are all defined. So when I define the property, that's where these actually come from, and that's why you have access to them. That's actually kind of cool. Let's bring this over here. Yeah, so the reason you can do a setter and deleter is because we've defined property, and then this property wrapper actually gives it a getter. So this is a getter, but you just use property to define the getter. Interesting. And then when those are defined, they get a self and a callable. Just any, it's a callable. Fget. Yeah, I'm just not seeing directly how this would apply to what we're doing. And then, of course, it's actually defined somewhere else. It's the only thing I could think of is passing this self, but there's a way to... Yeah, and these are not the same thing. A function. Oh, this already has the self associated with it. Yeah, that doesn't make sense, because you should just be able to call it, and it's going to be with nothing here. So yeah, I feel like this should work, but I know it's not going to. Do the insane... Wait, did that just work? Yeah, it just works. No. It's not decorated. That's why it's just working. No, it's not going to work. Even though it should. So whenever, yeah, we decorate it before. I feel like maybe we decorate it before it has an instance value. I'm not even sure. Yeah, this needs a. I need to do this offline and like dig deeper into this. But we'll wrap a function in a different area. So let's get out of this object-oriented programming stuff, and let's go wrap a normal function. And I will write a method decorator on another occasion. So my decorator.py. And we can get rid of this. I wonder if there's a lowercase any now. Nah. So now we have this class, myDecorator. My function. And we'll just send in an A and a B value and return the sum of those two things. So let's print so that we know we're inside the function. we'll print this inside the function thing here. And now down here, we will call the function. So and we'll do 1 plus 2 again. Okay, so you can see that it says that it printed out inside the function, and then it actually performed the function. So what happens, so I called this function, it sends in 1 and 2. This is just normal function behavior. We send in 1 to A, 2 to B. It prints out inside the function, and then we return the value of A plus B, and we actually get back the 2 here. So this is all just working. This is just a normal function call. Nothing special going on here. But now let's decorate it and just make sure that it behaves normally. So now we've decorated our function, and all that the decorator does is it grabs a handle to the function. So whenever it decorates this function, now we have this handle. This is like the my function goes in here into this function, and we save it inside of this instance of the class of the decorator. And then whenever we call my function, instead of directly calling my function, we're going to call the under call method here. And all of the arguments that go in here will be passed into args. All of the positional arguments will go into args. And any keyword arguments, we don't have any. But if we did, something like this, like if we had a keyword argument of 92, it would actually be passed into here. I got an unexpected keyword argument, so that's actually not surprising at all. Okay, and that's when we called this function, because this function doesn't take anything. Okay, so now you can see, so we're inside the function, and now we got this none type back because we did not return the value that was called. So whatever function that we're decorating, whatever that thing returns, we want our call method to return the same thing. So we're just chaining these things together. Down here, when we print my function, it goes. Now this thing is decorated. It goes to the call, and the args and KW args go in here, and then we can do stuff. But then we ultimately call the function we're decorating with the same values that came in. And then it performs this operation. This return value goes back to here, returns it from the callable from the decorator, and then finally it's going to print the value. So I do expect it to work this time. Yeah, we've made it all the way there. Okay. So what do we do with this, right? So what this allows us to do is it allows us to run code when we decorate the function. It allows us to run code before we call the function. It also allows us to run code after we call the function. So let's just throw some print statements in here so we can see what it's doing. I wonder if function has a dunder name. About to find out. Yeah. So decorating the function, my function. Oops. What am I doing? Okay, so decorating the function, my function. Now, when we call this, we want to print before calling the function. And then we can grab the results. And then down here we can return results. So now we have this before calling the function. We have this print function has been called. So this is after the function. And then we return the results. And then that goes all the way back to here. So now, just off of this one simple function call while we're decorating it, we can run all sorts of code that's wrapped around in front of and behind our code base, or behind our function. So now when we call just this one function with our print function, this decorating the function actually happens long before this. So let's add another print statement here and say before printing the function output. So this is like when you run this program, you would expect this to be the first line that you ever see, except it's not, right? Because we decorated the function before. So when this code runs, it kind of starts at the bottom. Okay, this class is defined. It runs into this decorator. We decorate this function. So it initializes the decorator with the function. So you can see that we get this decorating my function. Then finally it runs into this before printing the function output. And then whenever it actually calls this function, goes into here into dunder call, we hit this before calling function. And then it finally calls the function, and then you can see we get this printout that says inside the function. So we go from this call method back to the function that we decorated, and we finally start running it. And then we return the value. It goes into results. We print that the function has been called. You know, this is after the function. That's here. And then finally, the last thing that happens is those results that we captured from the function call are returned. They land here in the print statement, and finally, we get to see the output. So this is the overall flow of a decorator, and you can add things around your code that you might not normally be able to do. So you could do, so if every time you wanted to call a function, you wanted to log what it was called with, you could actually do that here. So you could do things like print, and then you could do your function name, and then you could say what it was called with args and args. And then maybe you want to say whenever you actually called it. So this would be an example of just trying to log the function call. Except we're just printing it. Okay, so now we have this line here, and maybe we give it some sort of info level. Just pretending like we're doing some sort of logging here. Okay, so now we have this info, my function called with args. These are positional arguments, 1, 2, and kwargs, and there are no keyword arguments. So args comes in as a tuple of arguments, and kwargs comes in as a dictionary of keyword arguments, and then we have the date and the time here. So if every time you called a function you wanted to do this and track what it was called with, like if you wanted to find out, just monitor the flow of your code, you're trying to track down an error, like, okay, what is happening before I run into this bug? You could put this decorator around your function, and now all of a sudden you have this logging function, like, or debugging function that's going to like help you really get a ton of information about it. So now if you wanted to just monitor a function. Instead of coming in here and having to put print statements and do it, you could just have a decorator that is like used for debugging, and then before it actually calls your function, it would go through this decorator and log your information out here to your terminal. And that is really the gist of just making your very own decorator. The sky's the limits on these things. You can see the type of absurd stuff that happens with these through the Fast API library that we kind of pulled up. Just shows like we have this. If the word async wasn't here, and it doesn't have to be, we just have this function called root, and it returns message hello world. But we put this simple decorator on it, and all of a sudden you have a backend server that responds with this message just because of this one decorator. Like, all of the magic of building a backend is by importing this app with an instance of Fast API and then using app.get as a decorator, and now this thing is a backend server. So you can see how powerful decorators can be through this example of Fast API. And decorators are used in things like TensorFlow for your data getters and things of that nature. But I do hear the dog calling. She needs to go out. So I think I am going to wrap this up there, and I will continue doing these. So if you are seeing this and you need some help with Python, just feel free to jump into the chat anytime and ask a question, and I will actually stop the random lessons that I'm talking about and try to help you with your problem. All right, thanks for watching.